All right, 2.7, use absolute value. Functions and transformations. So overall, you need to understand what the parent function of an absolute value looks like. Okay, so in the notes it showed you it's just a v, like this. And obviously different things happen that can flip it or shift it or whatever. So that's kind of more so what we're going to be doing today is basically the problem stated graph. I just want to know how it shifted. Okay, so we're kind of just doing the compare part. So with number 4, y equals the absolute value of x plus 2. And so the nice thing is once you kind of understand like the shifting for these, when we get to like parabolas and stuff, the shifting works the same way. So inside the parentheses, or in this case inside the absolute value bars, we go the opposite direction of the sign. Okay, so this is plus 2, so that means it's going left 2. Okay, outside it goes the same direction. So this one would shift left 2. And that's all I'm asking you to do for these problems. So if you go to check your answers in the back, it's not going to look like that because they're actually graphing them, other than you can figure out what they did to their graph. 6, f of x is equal to the absolute value of x minus 1 plus 4. So what does the minus 1 tell us that we were doing then?
Shift right 1.
Yep. And a lot of times I will just say, instead of writing shift, just because, you know, I like to write as little as possible, write 1. And then the stuff outside, it goes up and down, and it goes the same direction as the sign, so it's going to go up 4. Bless you.
Bless you. Bless you. It's a little late.
Too late to let somebody.
You're right. That was actually pretty good.
All right, 8, f of x is equal to negative 3 times the absolute value of x. So a negative sign in front of the x tells us that it's going to be reflected. Now, there's different things that happen based on where that is, but all I care about is for you to say that it's reflected. So basically, it's getting flipped upside down. So this is reflected.
Well, we have to graph these.
No.
Okay, but like on the test, I mean.
I may ask you to graph the parent function, and that is it. To show me what an absolute value graph looks like, which would just be to show me that it's a V. With a vertex at 0, 0, basically. All right, the next part of this is what tends to confuse people, okay, is this number that's here. A lot of people start thinking, because in the notes you should have seen that the absolute value of A, if it's greater than 1, then it's stretched. If it's less than 1, then it is compressed. But a lot of people get confused because they're like, well, A is greater than 1. And it's like, or like, you know, they'll start looking at it like that, or it's negative, so it's less than 1. And they get confused. We only care about the number itself, okay, the absolute value of it. So basically disregard the negative sign and just look at the number, okay? So 3 is greater than 1, so it is stretched. Writing it in that color. And the biggest thing that confuses people is if it's stretched or compressed. Everything else usually they pick up pretty fast. 12, f of x is equal to negative 4 times the absolute value of x plus 2 minus 3. So, y'all tell me what's happening with this one.
It is reflected.
Okay, it's reflected because of the negative sign.
Stretched because it's greater than 1.
Stretch because it's greater than 1, yep.
Yeah. And so left 2.
Left 2
And down 3.
and down 3.
Cooking. Yeah.
All right, one more like this, just to make sure we got it under control.
The negative number in front of the absolute value. It's stretched to that number is greater than 1.
But it's not. It's negative.
But I just in general.
Oh, okay.
The number itself, ignore the sign. So then with this one, what would be happening?
It's not. It is reflected.
Reflected.
This one?
No, not reflected because not a negative
It's
number.
depressed.
It's
Depressed. Yeah, it's depressed.
Okay, it's compressed because 1/4 is less than 1. So basically, it's only ever going to be compressed if there's a decimal or a fraction there. That's not a fraction that would be greater than 1, like 3/2 or something like that. Yes.
Would it be? It's not reflected because it's not a negative, right?
Right. So if there was a negative out front or right in front of the x, it would be reflected.
Is there an opposite to reflected?
No, it just would be just basically it's just normal otherwise.
Got it. Right 4.
Right 4
Up
and up 3. So yeah, so basically graphing the compressed and stretched part is super hard, which is part of why I don't do it, because unless you just plot points, most people don't understand what that means. But as far as graphing, so basically your graph goes from the origin, it gets shifted right 4, so that's going to be this way for y'all, and then up 3. And so the graph, the whole thing just moves, and that's all that's happening. Now, it's getting compressed, so that obviously is changing the opening of it, and that people get confused about that. So they usually have to plot points to figure that out. But you don't have to do that, just for reference for you. All right, the next one you're going to need your book open for to look at it. For 16 through 20. It's on page 127. What? Seniors will gladly take your money.
Yeah. I really want to see.
You're dating.
That's wrong.
All right, so 16, where we're going to start. So this problem, they give you a graph, okay? So this is where, now, I'm not going to give you a graph on a quiz or a test, okay? But I want you to be able to look at it and see what's happening. So basically, with 16, okay, we're looking at where is that vertex shifted, and that's how we write our equation, okay? So we always are going to start out with y equals, we are going to have an absolute value of x. So then how many places is that shifted over and up, like up? Obviously it's to the right and up. So how would I write this?
X minus 1.
It's only over one spot.
Wait.
You're looking at how many places on the graph it shifted over. So it's minus because it's right.
Minus. Yeah. 1. Minus 1.
No, not from the origin.
From the origin.
Oh.
1, 2, 3, 4.
That's why I was like, huh?
4.
5.
4.
4.
Dummy.
Okay. So that's the inside part. Now it shifted up how many spots?
1.
4.
3?
Plus 4.
3. Oh, my
3.
gosh. I'm so smart.
I don't really know why they put a second point on there. It kind of irritates me.
Yeah,
Because it's unnecessary.
That's what was tripping.
Oh, yeah.
Which point is it?
The vertex.
Vertex.
Oh.
The part where it goes
So with those ones, you just have to look at it and write your own equation, basically.
down. Okay, this is pretty simple.
18. So what's happening with this one?
It's just x to
Y equals X.
Well, what do you first of all notice about the graph?
It's on the y-axis.
Negative?
It's
So a graph normally, yes, it's going to be negative. Okay, graph should look like this, but it looks like this. Okay, so it's going to be negative. So out in front of the absolute value, I need to put a negative. Then I've got x, and then is it shifted right or left?
No.
Okay, is it up or down?
Yes.
Yes. It's up to
Okay, so it's going to be negative absolute value of x plus 2.
Good job.
All right, now 20, I'm going to do this one, but just to show you, this is why the points are coming in handy with what they're giving you. So 20, we've got y equals, all right, so leave a space and then write your absolute value because I'm going to show you how to figure out what goes in front. So I've got x, is it right, left, up, down?
Right. 1, 2, 3, 4, 5. -5.
So -5, and then up or down?
Up. 2.
So plus 2. So now the part that goes in front, okay, this is where the point is coming in handy. So basically, the number that goes in front, you can kind of think of like slope, okay? So notice that now it's not going to be negative because the graph is up, but the point, they put the point on the left side this time. They've been putting it on the right side. Oh, well, I guess some of them it's on the right, some of them it's on the left. So basically, we're going to go to the next point that we know. So that point is the point that's marked, okay? So that's up 2 and left 1, or we could have gone up 2 and right 1. So we see the slope. You see what I'm talking about?
Yes.
We counting that? Okay. So basically, whatever the slope is going in front. That's how we would be doing it if we were graphing it. So there's one, like 19, for example. If you look at that one, that's up 1 and right 2. So the number going in front would be 1/2. Okay.
Wait, so do the off numbers in front? Or
No, the other ones we had did not,
no? Okay.
because it was just up 1, right 1. So like if you go back to 16, the second point that's on there, if you go up 1, right 1, that's how you get there. So basically there's an understood 1 in front. We don't need to write it. Just like we wouldn't write slope if it was just 1 in general. Any questions about that?
No.
All right. Well, then we're done. So your problems are 5, 9, 11, 13,
Yeah.
15, 17, and 19.
On the same page.
Yeah.
Oh.
So, and again, you're not graphing anything. You're literally just writing words or the equation for 15, 17, and 19. So 17, actually, so 15, 17, and 19 all have a number in front. So you just need to look at the slope number that gets you there. And remember, you only put the negative if the graph is upside down.